Hi everyone. Today I'm going to talk about the investigation of light trigger metallo-drugs for photodynamic inactivation of bacteria. In order to give a slight background about the photodynamic inactivation, what PDI is, let's just look at this energy diagram. Here you can see that TS refers to the abbreviated form for the photosensitizer, which is the molecule or the antimicrobial molecule that we are testing. The singlet photosensitizer molecule here refers to the ground state of the photosensitizer, which is activated by the illumination with a particular wavelength of light. This ground state molecule is excited to its singlet excited state molecule, where it undergoes electron spin to form a triplet excited state. This triplet excited state of the photosensitizer undergoes two types of reactions. One is electron transfer, another is energy transfer through the formation of the singlet oxygen and the reactive oxygen species of the molecular oxygen present in the environment in order to go back to its ground state. These reactive oxygen species and the singlet oxygen molecules formed while the conversion of the photosensitizer or excited state photosensitizer back to its ground state are responsible for the antimicrobial activity that is observed. The key objective of our lab are to design the photosensitizers in such a way that we can increase the lifetime of the triplet excited state of the photosensitizer. Increasing the lifetime of the triplet excited state can increase the chances of the formation of reactive oxygen species, such as including the singlet oxygen species of the molecular oxygen. And the formation of more and more reactive oxygen species can lead to showing more antimicrobial activity. Let's just talk a little bit about the photosensitizer design, which is followed by our lab. We designed ruthenium or osmium-based molecule, out of which I'm talking about the ruthenium-based coordination complexes here. This ruthenium-containing metal center is attached with the CF3 group containing co-ligand, a CF3 group containing BP ligand, bispiridine ligand. In order to increase the lifetime of the excited state of the photosensitizer, we pi expand our molecule. Such as here, we followed by the introduction of the phenanthralin ligand instead of the homoleptic ligand, the co-ligand. Further, we pi expand by the introduction of the thiophene residues. We vary the number of thiophene between 1 to 4 to increase or pi expand the photosensitizer and increase its lifetime. In order to determine the lifetime of the photosensitizer or excited state lifetime of the photosensitizer, we determine the transient absorbance spectra of the molecule. Here you're looking on the left side is a transient absorbance spectra of a ruthenium molecule containing 4 thiophene residues, which is the highly pi expanded molecule. Using this TA spectra, we determine the lifetime of the intermediate triplet excited states of the photosensitizer. So this singlet MLCT is the metal to ligands charge transfer state, which are one form of the excited states of the photosensitizer, and triplet ILCT is another intermediate form of the excited state of the photosensitizer, where ILCT refers to the intraligand charge transfer state. And this triplet ILCT state is the one responsible for the formation of reactive oxygen species. Furthermore, we also determine the lipophilicity of the compounds by determining the distribution coefficient shown on the y-axis here in octanol, O, and water, the lipophilic, octanol, and the hydrophilic water phases. And the higher the log D value is, the more lipophilic the compound is. The lower the log D value is, the higher the hydrophilicity of the compound is. And with the pi expansion, we observe that the lipophilicity of the compounds are also increasing. Furthermore, we determine the photobiological activity of the compounds in both gram-positive and gram-negative bacteria, such as gram-positive is Staphylococcus aureus, and gram-negatives are the Acinetobacter baumannii and Escherichia coli, under both dark and light conditions. We determine the EC50 values here shown on the x-axis, which is the concentration of the compound where the 50% inhibition in the bacterial growth is observed. We saw a completely opposite trend of the EC50 values between the gram-positive and the gram-negative bacteria. In order to understand more about the photobiological activity that we observe between these two kinds of bacteria, I would hope that you guys can come and look at my poster. Thank you so much for your kind attention.